Hello, and let's talk about section 3.3, and this time we're going a little bit further into linear functions. In section 3.2, we introduced the idea of functions. This time we're going to talk about linear functions. And a linear function, of course, the definition is always in order, is an equation that can be expressed in the form y equals mx plus b, and whose graph is that of a straight line in the coordinate plane. We actually looked at one like that, but let's go through this again. One thing that we should try to do if we're graphing is ask ourselves, well, how many points do I actually need to plot the graph of a line? The answer to that, very simply, is that we need a minimum of 2 points. Why? Well, if you think about it, it makes perfect sense. We need 2 points because if we graph a line, if we've got 2 coordinates based on the graph, based on the function, all we need is a ruler and a sharp pencil, and we're pretty good. However, for accuracy, we're going to use 3. All right, so we're going to use 3 points right here, and this is our graph. We're going to graph the function f of x equals negative 2/3 x plus 2. Now, a question should come up, how should I choose points? And one of the most basic ways might just be to substitute in values like 1, 2, -1, just random points. However, we can be a little bit smarter about it. How do we pick the points? Well, I will say that one point that you should always pick, if you're going to graph a line, pick a point where x is equal to 0. Right? Why? Well, in a case like this, of course, if we find the value of the function at x equals 0, it's an easy number to work with because negative 2/3 doesn't matter. We're multiplying it by 0 and then adding 2. And so what we're going to find is that the value of the function at 0 is equal to 2. All right, well, how about some other points besides 0? That's an easy one. For me, the best way to choose a point would be to look at the denominator. If you've got a fraction, if you've got a fractional multiply for x, look at the denominator. In this case, the denominator is 3. So if we're going to pick a point, spell denominator there best I can here, denominator is equal to 3. So that means what we should do is that we should pick points that are multiples of 3 if we are going to choose many points. So let's just choose the basic multiple. Let's try x equals -3 or x equals +3. Now we could have also picked x equals 6, x equals 9, x equals -6, any other number of points, but these are really just being picked for convenience. So all right, let's take a look what happens at -3 if we substitute that in. Let's take f of -3 is going to be -2/3. I'm going to write a little bit smaller here, times -3 plus 2. The reason why we wanted to choose 3, because the denominators cancel. We're left with -2 times, if we cancel, -1. So f of -3 is equal to +2 plus 2. The result is 4. This means that we have the coordinate point on our graph of -3, 4. Let's try it at x equals 3. If we choose f of 3 and evaluate our expression, we're going to take -2/3 times 3 plus 2. When we work this through, we divide out the common factor right there. We're left with -2 plus 2, which very nicely adds up to 0 and gives us a coordinate point now at +3, 0. And our third point for accuracy was the point 0 for x, 2 for y. So if we plot those, let's take a look. We have -3, 4. We have the point 0, 2. And we have the point 3, 0. Well, that's easy enough. All we really have to do is fare some line right through there. And let's see if we choose our points accordingly. See our graph passing through these 3 points right there. And that's a graph of our line.